Hello everybody. To further continue in this chapter, we are going to discuss about diagnostics in onboard charger and EVSE interface. I will tell you what is meant by EVSE interface. Right now, you note down just the acronym. Diagnostics in onboard charger and EVSE means electric vehicle supply equipment interface are critical for safe, reliable and standardized compliant charging operations in electric vehicles. So you should understand that charging the vehicle cannot happen in a haphazard manner. It has to happen in a very organized and standardized manner so that it is safe and reliable. Last thing you want is vehicle catching fire during the charging of the vehicle. And these diagnostics cover both the alternate current and direct current charging scenarios and involve detecting faults in power conversion, communication, and interfacing layers between the EV and charging infrastructure. Now, when it comes to system overview, onboard charger and EVSE interfaces. All right. So when it comes to onboard charger, it converts the AC from EVCU supply equipment into direct current for charging the high voltage battery. Now coming to the key components, AC DC converter, power factor correction stage, again DC DC converter, communication unit for control pilot, proximity pilot, and CAN EVSE interface. Now other important components interfaces with the EV with external AC or DC charging equipment. It also includes control pilot, proximity pilot, and communication protocols. Also, it takes care of the pulse width modulating signaling, the PLC and CAN communication. Now, talking about the diagnostic goals, what are the main goals? First is the safety. When you mean safety, you mean to prevent the over voltage, over current, ground faults, and overheating. Now, when it comes to reliability, ensure fault tolerant and consistent charging. Compliance, meet standards like ISO 15118, IEC 61851, SAE J1772. Now, coming to the serviceability, log diagnostic trouble codes and support root cause analysis. And when it comes to interoperability, identify faults with EVSE miscommunication or misbehavior. So these are the various diagnostic goals and its respective description. Now, when it comes to key diagnostic functions in OBC and EVC interface, the first function is power electronic diagnostics within the OBC, within the onboard charger to diagnose the power electronics. First is input over voltage, under voltage detection, and it detects the voltage outside limits, for example, less than 90 volts or greater than 270 alternate current for level 1 and level 2. And it may also cause charger to reject the charging session. Now, when it comes to overcurrent protection, input and output current monitored triggers fault if current exceeds design limit. Example 32 ampere for AC charging. Now, when it comes to PFC and DC-DC stage faults, faulty PFC, low efficiency distortion heat, DC-DC failure, the failure to boost voltage to high voltage battery level. And next important function is over temperature monitoring. Now, what is this over temperature monitoring? These internal sensors monitor thermal rise in key components. Also, fan and cooling the diagnostic include. It also includes the cooling the respective diagnostics to maintain the required temperature. Now, when it comes to ground fault detection, leakage to chassis ground typically required for safety compliance as per the standards IEC 62752 and UL 2231. Now, when it comes to communication diagnostics from electric vehicle to electric vehicle supply equipment, first is the control pilot signal monitoring. PWM signal carries the charging state, current capability, and second is faults, incorrect duty cycle, missing cycle, short to ground. So these are all the various faults that can sprout up when you are doing the control pilot signal monitoring. Next is proximity pilot faults and indicates the cable ampacity. Now, when it comes to faults, incorrect resistance range and open circuit. So these are the faults that can pop up during proximity pilot faults. And when it comes to ISO 515118 DIN 70121 communication issues, it is used in DC or high power AC charging. And when it comes to diagnostics for message timeouts, CRC mismatch errors, and authentication handshake failure. Now, when it comes to PLC modem diagnostics, power line communication chip faults, and internal health checks. So these are the various activities that happen when it comes to PLC modem diagnostics. Next is taking care of the isolation and safety diagnostics. When it comes to insulation, detect the leakage between high voltage bus and chassis during and after charging. This is how you monitor the leakage between HV bus and chassis. And next is this is typically required before activating DC relays. Now, when it comes to HVIR monitoring, high voltage interlock loop ensures charging connector safety, and open loop disables charging system. Now, when it comes to for functional monitoring and charge status mismatch, expected versus actual charge power based on state of charge, battery temperature, and or BMS input. Now, when it comes to timer or watchdog diagnostics, detect stuck or unresponsive states in OVC control software, and contactor stuck or misoperation. Now, when it comes to it verifies the proper contactor engagement before the power delivery. Now, these are how you actually monitor the functioning. Now, when it comes to EVSE interoperability faults, I mean the faults that can come up between when EV is interacting with the infrastructure. The first fault is plug detection fault, and the description is EV does not detect plugged in status due to CP PP line error. So even though you plug in, it does not EV does not detect the plug-in status. That is the first fault. And second is EVSE communication timeout. EV does not receive expected handshake. All right, it does not receive the expected approval. So that is called this EVSE communication timeout. Now, when it comes to EVSE capacity mismatch, EV expects more current than EVSE can provide. And when it comes to emergency shutdown, EVSE command to abort charging due to internal fault. All right. Now, when it comes to stuck relay in EVSE, it detects if voltage appears at the connector without EV request. All right. So these are the various fault types that need to be kept under vigil by the help of the diagnostics. Now, what are the common diagnostic codes when it comes to the charging point? The first diagnostic code is POD08 D0A. The description is onboard charger input over voltage. Second is P0D0B, and comes the thing is it is exactly same except that it is under voltage. Above is over voltage and this is under voltage. Now P0D0F, it means that onboard charging has some internal failure. And when it comes to P0D12, control pilot fault. And when it comes to P1C6A, communication error with EVSE. Now P0AA6, HV insulation fault detected during the charging. Okay. Now, when it comes to diagnostic testing strategies, these are the various types of strategies which I mentioned here, and I'll also give a brief description. The first type is startup self-test, validate CPPP, circuit integrity, PFC health, and sensor status. Now, when it comes to real-time monitoring, single voltage current, duty cycle temperature. Okay, this is another type of the test. And third is periodic diagnostics, performed every charging cycle, and it also, for example, it monitors the insulin resistance at a very periodic interval. Next is fault injection testing, used in validation to simulate communication or power faults. Next is service tool diagnostics, and it also accessed via OBD or diagnostic port. So these are the various types of strategic testing, testing strategies. Okay. To further proceed, now, like every application, even charging application must fall under the purview of functional safety. And when it comes to functional safety, this is usually ASIL B or ASIL C because this has a level of injury accompanied to it. So in case of any kind of in case of any kind of any mistake or any kind of any failure, this can lead to this can lead to a injury, deep injury to the user. So it falls under ASIL B and ASIL C. Now coming to the cyber security requirements, ISO SAE 21434 mandates secure diagnostics and EVSE authentication. All right. So it should also prevent the spoofing of CP and PP signals or PLC messages. All right. Now when it comes to tools used for development and testing, now Vector, Cano, ETA, Synca, and interface and diagnostic testing. And charger emulators, example Phoenix Contact, Grid Sim, hardware in loop test platforms. For example, hardware in loop test platforms. This is also an important tool. And another tool is oscilloscope to confirm the signal integrity and power fault detection. Last but not the least, the OBD scan tools for fault code reading and logging. So to summarize, these are all the various types of diagnostic areas: the power path, thermal aspect, the communication, the insulation, the interoperability, the software system. And what are the key checks when it comes to power path? Over voltage, over current, PFC, DC faults. Now, when it comes to thermal, over temperature and cooling diagnostics, and when it comes to communication, CP, PP, ISO 15118, DIN 70121 errors, leakage detection before charging. Now, when it comes to interoperability, faults with EVSE handshake, and when it comes to watchdog software system, watchdog timer overrun software reset. Okay, so these are the various aspects of the diagnostics that need to be covered as far as the charger is concerned. Electric vehicle to electric vehicle supply equipment is concerned. These are all the various diagnostics that need to be extensively monitored and covered. Thank you.